Hi, my name is Heather Hunt. I go to the Colorado School of Mines, and I'm from Colorado also, native. The title of my poster is Creating Atomically Smooth Surfaces on Zinc Oxide Single Crystals to understand modifications of zinc oxide nanorods, and the use will be for hybrid photovoltaics. So basically with hybrid photovoltaics, they work like any other one, just your standard photovoltaics, but you have your metal oxide that works as your electron transporter, and then we put an organic polymer inside of that to work as the hole conductor. And so the farther in that your polymer can go into your zinc oxide nanorods, the better your solar cell will work. And so in our group, we've been working on how to make that happen. And we found that by treating the zinc oxide nanorods first with a chemical like ODT, which is octadecane thiol, we found that you have the polymer inserts better in them, and you get a higher photocurrent, which is good for your solar cells. And so my research has been to take these nanorods, which have 3 different possible sides. They have a top, a bottom, and a side. And by taking those 3 different sides and treating those 3 different sides individually with ODT, and then seeing what happens to that. And my summer research so far has been finding a mechanism to make sure that we actually get the correct top, bottom, and side morphologies, because we can order the single crystals, which is how I do it. So we have the zinc oxide nanorods, and I order single crystal versions of the sides that we're interested in. And these single crystals come from the manufacturer looking like this, which is not useful, it's not ordered, and we don't really know what's on it. So my project was making a device that could give us nice, uniform, well-defined terraces, which would then be useful to study later. And so in order to do that, I created a zinc oxide ceramic box. I basically took a zinc oxide ceramic target and cut it into pieces and then bonded it back together. And I put my sample in this little box and I anneal it in a furnace. And it comes out as like this. And it comes out in well-defined, like I said, well-defined terraces, which I then can use to study the nanorods. So once I get these well-defined surfaces, my future work, well, this has been my work so far, was making these surfaces, and my future work will be to deposit the chemicals on it that make the nanorods work better, and then study them as a whole to figure out what they go on.